Next chapter, polygons. A polygon is a closed flat shape with straight edges. Closed means there are no gaps in the shape. Flat means it lies on a single plane. And straight edges means it is not curved at any point. Polygons are given names according to the number of sides. A three-sided polygon is called a triangle. A four-sided polygon is called a quadrilateral. Beyond four sides, the names follow a particular pattern with a common suffix. A five-sided polygon is called a pentagon. A six-sided polygon is called a hexagon. A seven-sided polygon is called a heptagon. An eight-sided polygon is called an octagon. A nine-sided polygon is called a nonagon. And a 10-sided polygon is called a decagon. As you will notice, the sides of a particular polygon need not be equal. Triangles. A triangle is a polygon with three sides and three angles, and it is the simplest polygon. Simple as they may look, triangles are perhaps the most useful polygons in the study of mathematics. Trigonometry is the study of triangles. One reason why triangles are so important is that more complicated shapes can often be divided into triangles, and using the knowledge of triangles, we can be able to find the sizes of sides and angles of the original shape. The sum of all the interior angles of any triangle is equal to 180 degrees. Triangles are named based on angle sizes. If all the three angles are less than 90 degrees, we call it an acute triangle. If one of the angles is 90 degrees, we call it a right triangle because it sits upright. The 90 degrees angle is called a right angle and is indicated with a small square. If one of the angles is larger than 90 degrees, we call it an obtuse triangle. The larger angle is called an obtuse angle. Triangles can also be classified based on the length of their sides. A triangle with all the three sides different from each other is called a scalene triangle. A triangle with two equal sides is called an isosceles triangle. In this kind of a triangle, the interior base angles are equal. And a triangle with all the three sides equal is an equilateral triangle. Here, all the angles are also equal and are 60 degrees. Exterior angles of a triangle. This is a simple triangle. All the three inner angles are called interior angles. An exterior angle is formed by extending any of the three sides beyond the vertex. So this is an exterior angle. At this point, let us name the interior angles as A, B, C, and our exterior angle as D. Now with respect to the exterior angle D, angle C is called adjacent angle. So we say C and D are adjacent to each other. Then, the other two interior angles A and B are said to be opposite to angle D. It has been found that the sum of the two interior opposite angles equal to the exterior angle. And it is easy to prove that. First thing we notice is that the angles C and D are on a straight line, and so C plus D is equal to 180 degrees. We call that equation 1. Again, we know that the sum of all the interior angles of a triangle is 180 degrees, and so A plus B plus C is equal to 180 degrees. We call that equation 2. Now imagine we rearrange equation 1 and take C to the right hand of the expression. We shall have D is equal to 180 minus C. We form equation 3. Then we also rearrange equation 2 and again take C to the right hand of the expression. We shall have A plus B is equal to 180 minus C, and that is our equation 4. Looking at equations 3 and 4, the right-hand side is the same, that is 180 minus C. It then follows that the left-hand side must also be equal, and that is D is equal to A plus B. And so in general, the sum of the two interior opposite angles of a triangle equals to the size of the exterior angle. So if you have this kind of a triangle, we can find D. C plus 105 is equal to D. C and 105 are interior opposite to angle D. Then again, C and 135 degrees are angles on a straight line, and so C is equal to 180 minus 135, which gives us 45. And therefore D is equal to 45 plus 105, and that gives us 150 degrees. Next, quadrilaterals. A four-sided polygon is called a quadrilateral. Quad means four and lateral means side. Quadrilaterals are given specific names depending on whether they have parallel sides or equal angles. A rhombus has all its sides equal in length. These sides do not necessarily meet at right angles. While the diagonals of a rhombus meet at right angles, they are not necessarily equal in length. In a rectangle, the opposite sides are equal in length and each pair of sides meet at right angles. The diagonals are also equal in length, but they do not meet at right angles. A square has all its sides equal in length. Each pair of its sides meet at right angles. A square has two equal diagonals that meet at right angles. A trapezoid or trapezium has only one pair of parallel lines. A parallelogram is like a rectangle, except that its diagonals are not equal in length and the sides are not perpendicular to each other. When a four-sided shape does not fit any of these categories, it is simply called a quadrilateral. Interior angles of a quadrilateral. Angles in any quadrilateral add up to 360 degrees, and these are the interior angles. It is easy to see where that comes from. This is a rhombus. What we can do is draw a line through any two vertices and split it into two triangles. Now we know that angles in a triangle add up to 180 degrees. So we have 180 in one triangle and another 180 in the other triangle. So in total we have 360 degrees. So if, for example, we have this quadrilateral, we can find x. We do x is equal to 360 minus 100 minus 60 minus 95, which gives us 105 degrees. You will see that dividing a polygon into triangles is key to finding the sum of the interior angles of polygons. Let's do that. We look at interior angles of a polygon. Now, a polygon may be regular or irregular. A regular polygon has equal sides and equal angles, and an irregular polygon is just the opposite. Incidentally, the number of interior angles in any polygon equals to the number of sides. To find the sum of the interior angles of a quadrilateral, we divided the figure into two triangles. Equally, for any polygon, we divide it into the possible number of triangles. So if we have a pentagon, it can possibly form three triangles. Each is 180 degrees. So the sum of the interior angles of a pentagon is 3 times 180, which is equal to 540 degrees. In a hexagon, we shall have 4 triangles, giving us 4 times 180, which is equal to 720 degrees. Generally, for any polygon with n sides, we can form n minus 2 triangles. And so in total, we shall have n minus 2 times 180 degrees. This is the formula for finding the sum of the interior angles of any polygon, regular or irregular. Now for an irregular polygon, we cannot know the size of the specific angles unless we measure them individually because they are not equal. However, for a regular polygon, it is possible to find the size of individual angles because they are all equal. And the way we do that is to divide the sum total by the number of angles. And if you recall, we have said the number of angles equal to the number of sides. So we simply have n minus 2 times 180 divided by n. So for a regular octagon with 8 sides, we shall have 8 minus 2 times 180 divided by 8, and that gives us 135 degrees. Lastly, exterior angles of polygons. This is a regular pentagon. So what are the exterior angles? We get exterior angles by extending each side at each vertex of the polygon. And it is important that you keep going in the same direction. So these are the exterior angles of a regular pentagon. And again, they are equal to the number of sides, 5 in this case. The thing is, all exterior angles of a polygon add up to 360 degrees. And it is easy to understand why this is the case. Here, we start with an orange arrow pointing in one direction of the polygon. And what we will do is take the arrow through all the extended lines and notice how much the arrow will rotate. So we rotate anti-clockwise through the first exterior angle. We do not change the direction of the arrow, but we move it to the other vertex. Another anti-clockwise rotation, and without changing its orientation, we move it to the third vertex. We keep doing that, rotate and move. Rotate, move. Finally rotate and move back to where we started. Did you notice the arrow made a whole turn? This is the 360 degrees we are talking about. For regular polygons, all the angles are equal, and so we can find the size of the individual angles. We simply divide 360 degrees by the number of angles, which basically equals to the number of sides, that is 360 over n. And so for a regular hexagon, we shall have 360 over 6, which is equal to 60 degrees. And so each exterior angles of a regular hexagon measures 60 degrees. Take an example. Beforehand, Notice that even quadrilaterals are polygons. So for this quadrilateral, we can find x. We know that all exterior angles add up to 360 degrees. And so x plus 100 plus 80 plus 60 is equal to 360 degrees. X is equal to 120 degrees. It is important to note that at the vertex, the exterior and interior angles are supplementary. Last example. The sum of the interior angles of a regular polygon is 1440. A. What is the name of the polygon? And B. Find the size of the exterior angle. In our solution for A, to be able to find the name of the polygon, we need to find the number of sides, and we know the number of sides is equal to the number of the interior angles. So the formula for calculating the sum total of the interior angles is n minus 2 times 180 degrees. So we equate that to 1440. So we have n minus 2 times 180 is equal to 1440. We divide both sides by 180, and if we solve that, n is equal to 10. So the polygon is a decagon. Exterior angle is given by 360 over n. So we have 360 divided by 10, and that is equal to 36 degrees. Good luck with polygons.
The way we teach it in university and in high school as well, in colleges, is if you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor. It applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs, and once it starts going downhill, you're in trouble. And so the biggest secret, or the biggest piece of advice, is get help early from as many people, and there's lots of sources for help, that other students in the course, teachers, etc. And so go there for it, and go early, and go as often as necessary.